So those symbols can come from an English name, a Latin name, or even it was named after a scientist. Okay, so the names come from a wide range of things, right? We could talk about chlorine. Chlorine, fun fact, is so that name was derived from the Greek word. Okay, so it's derived from a Greek word. The word is called chloros. Chloros. Now, the reason why it's chloros is because if you guys ever seen chlorine in its natural state as a gas state, right? It looks like a pale green color. And hence, that's where it's getting the name from. If we think about sodium, right? Sodium, we say sodium, Sodium, but the symbol is Na. Where did they get Na from? Well, that name, right, came from a Latin name, natrium. Okay. Or even, there's been cases where we have elements that are literally named after a scientist. Okay. Istonium. Y'all guess where that came from? Let me move out the way. Came right, Einstein, right? It came from Einstein. Okay. So these symbols come from a variety of different ways. Okay. So anybody ever discover a new element out there, you might have a shot to name it after yourself. Atomic number is the amount of protons for that element. So since each element has a different amount of protons for each, that means that each element is going to have a different atomic number for each as well. Okay, because the atomic number is the amount of protons for that element. Now that element can be classified into like three classifications. We have metals, nonmetals, and metalloids. Okay, I'm just going to give you some basics to these. Throughout the semester, we'll probably go over these, and Chem 2 will mention this more. But with the metals, basically, you want to know that metals are good conductors of heat and electricity. They're malleable, so you can pound them flat. They're shiny. And then metals like to lose electrons. Okay, so metals do love to lose electrons. We'll cover that more. But just understand, right, that they like to lose electrons. A good example of metals are like copper. What else? Any transition metal, rhodium, etc. Okay. Non-metals. So non-metals are basically poor conductors of heat and electricity, so the opposite of that end. And they like to gain electrons. Okay, so they're usually going to gain these electrons to form those anions. Okay, so remember, thinking back to cations, anions, right? If you lose electrons, you're going to become more positive. You're a cation. If you gain electrons, you're becoming more negative. You're an anion. Okay. And then this can vary, so they can vary in a physical state at room temperature. Okay, so non-metals, even though it's a non-metal, they can either be a gas or a solid or a liquid in some cases. So a good example of a non-metal is like oxygen or carbon. Okay. And then lastly, we have metalloids. So metalloids are they have a mix of properties. Metalloids are usually known to be good semiconductors. A good example of a metalloid is silicon. All right, the periodic table. This is first. I'm going to cover what we call groups or families. Okay, because remember, right? The reason why we're calling them groups or these families is because they have similar properties. They have similar properties. When we look back at the periodic law, we understand, right, as we increase 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as we increase in mass, right, certain properties are going to reoccur over and over again. Okay? Over and over again. Shout out to Nelly. All right. So anywho, first group is we have group 1A. 1A. And we're going to get to 1A in a bit when we talk more about ions. But just for now, just remember that this 1A, if you ever see that on the periodic table, that's the group number. Okay, so group 1A, okay, is alkali metals. Okay, this entire column, right? This entire column, starting right here, alkali metals. Okay, and then also, and when I'm saying group 1A, We're not going to include hydrogen in this group 1A. We're talking about really with lithium and down. Okay, so lithium and down. Hydrogen is kind of on its own. Okay, it's doing its own thing. But from lithium and down, right, we're going to see very similar properties. Now, these are alkali metals and they're very reactive. They're very reactive. Lithium, sodium, potassium, every single one of these metals can react in the air if you leave it out. Definitely they can react with water. They're very reactive metals, okay? And because of this, right, they have this similar property being reactive metals. So this group 1A, alkali metals. Write that down. Write that down. Okay. Group 2A. Group 2A. So this is the second column here. Second column. Group 2A is alkaline earth metals. Okay, alkaline earth metals. Okay, so these are fairly reactive metals. They're not as reactive as group 1A, but they are still reactive metals. Okay, so we're usually going to see this with magnesium, calcium, those type of metals. Okay, having those similar properties of being fairly reactive metals. I'm going to jump over here, but I'll come back here. And then next is group 7A. So group 7A is a main group element. Okay, so group 7A is halogens. These are very reactive nonmetals. Okay, so basically, once again, right, these are reactive nonmetals, chlorine, right, bromine. We talked about these reactive gases that we've heard and seen before. So these are halogens. And then we have group 8A, group 8A. So these are all noble gases. These are basically very close to being unreactive for most of these. Neon, argon, etc. So the noble gases, they're not going to react with many things. Okay. So I'm just covering the main groups, 1A, 2A, 7A, 8A. And these are all things that have similar properties. Now, I just want to look at the blue real fast before we move on. The blue is transition elements, okay? They have some similarities within their own right? They're all metals, and in this case, transition elements will have multiple oxidation states. Now, since we just covered the periodic table, I want you guys to start thinking about how these ions are being formed, right? So we've been mentioning, right, ions have a charge on them, okay? And that charge is coming from either you're losing electrons or you're gaining electrons. So we look here, right? A main group metal tends to lose electrons. Okay, so we need to understand a main group metal tends to lose electrons. As I mentioned before, with the characteristics, metals like to lose electrons. Okay, metals like to lose electrons. Okay, so when they lose this electron, they're going to form a cation. Okay, so this cation is being formed here. So what we need to understand, and there's a whole unit we're going to talk about this, but for now, right, once those metals, so in this case, these are our metals over here, these metals are losing electrons to become this positive cation. So right now, these are cations, right? Because we know that with this top right hand, we see that charge symbol there. So we know that it's an ion. Anytime that there isn't a charge symbol here, right? Any type of symbol top right hand, it's probably going to be a neutral atom. Okay, so it's just a neutral atom, not an ion. Okay, now when they form this cation, this means that they are going to have the same number of electrons as the nearest noble gas. We're going to talk about this a lot more in detail as we go in the semester, but for now, right, I just want you guys to know that when we're forming these ions, the metals are losing electrons to form those cations. Okay, and if we look on the opposite end with the nonmetals, they like to gain electrons. They like to gain electrons. Okay, so they're going to be forming an anion with the same number of electrons as the nearest noble gas. Okay, so basically, here's a hint just to let everybody know. Everybody want to be like a noble gas. Okay, that's as much as I'm going to tell you for right now. Okay, But right now, everybody wants to be like a noble gas. Okay, we're going to get more in detail with this when we talk about electrons and all that jazz. But for now, I just want you guys to understand that an ion, okay, we have two different types, cations and anions. All right, and the metals like to lose, anions like to gain. Okay. And then we'll go over specifically why certain anions, right, have a -1 versus a -2, and why certain cations have a +2 versus a +1. All right, stay with me, guys. We're going to be there. We're going to get there.